So in algebra, looking at number 914, the quadratic formula is only one of the tools you can use to solve quadratic equations. What do you think the other methods you can use? What other methods do we know? Well, a quadratic graphs a parabola, so we could graph and find our x-intercepts. We could use our box and cross method, and we could factor. Or, if neither one of those worked, then we can use our quadratic formula. And number 15 says, use the quadratic formula to solve the equations below for x if possible. Check your solutions with your graphing calculator. So if I'm going to use my quadratic formula, I like to write out what is the quadratic formula. Negative b plus or minus square root of b squared minus 4 times a times c all over 2a. So let's look at a. 3x squared plus 7x plus 2 equals 0. And let's list out, what is my a value? It's the number in front of the x squared term, so a is 3. b is a positive 7, and c is my constant term, 2. And let's start filling it in to our quadratic formula. The opposite of b plus or minus square root of b squared, I like to use parentheses there in case b was negative, minus 4 times a times c all over 2 times a. So we've got our numbers plugged in. Now we just want to start evaluating all numbers. Don't forget this is actually what we're solving for. What does x equal? So let's start simplifying. Change of color here. Negative 7 plus or minus. Inside my square root, I've got 7 squared. 4 times 3 times 2, 24, all over 6. 49 minus 24, that's a nice convenient number. 25 over 6. What is the square root of 25? Ah, that's nice too. X equals negative 7 plus or minus 5 over 6. And then let's finish it. I'm going to rewrite it twice. X equals negative 7 plus 5 over 6, or negative 7 minus 5 over 6. Negative 7 plus 5 would be negative 2, over 6 would be negative 2/6. Negative 7 minus 5 would be negative 12 divided by 6 is negative 2. Great. All right, let's look at b. 2x squared minus 9x minus 35 equals 0. So my a value is 2. My b value this time is a negative 9. And my c value is negative 35. Let's plug them in. Negative 9 plus or minus square root of negative 9 squared minus 4 times 2 times negative 35, all in parentheses because we're going to end up with some negatives times negatives in there, all over 2 times a. Perfect. Negative 9. Let's call that 9. Plus or minus 81 plus, because I've got the negative 4 times 2 times negative 35 plus 280 divided by 4. 2 more steps, I think. X equals 9 plus or minus square root of 361 over 4. Checking the square root of 361, x equals 9 plus or minus 19 over 4. So let's write it out. X equals 9 plus 19 over 4, or 9 minus 19 over 4. 28 divided by 4 is 7, or negative 10 over 4. Let's call that negative 5/2. Got our 2 answers. Continuing with C, 8x squared plus 10x plus 3 equals 0. A equals 8, B equals 10, C equals 3. Negative b plus or minus square root of b squared minus 4 times a times 3 all over 2 times a. Good deal. Start simplifying. Negative 10 plus or minus 100 minus 96 all over 16. Do a little more simplification. X equals negative 10 plus or minus square root of 4 over 16. Square root of 4 is 2. X equals negative 10 plus 2 over 16, or negative 10 minus 2 over 16. Negative 8 over 16 is negative 1/2, and negative 12 over 16 is going to give me negative 3/4. 1 left. Let's try x squared minus 5x plus 9 equals 0. Always writing down a equals. Now, there's no number. I think a common algebra mistake there would be to write x squared. But if there's no number written there, we always know that there could be a 1 written. So a equals 1.
Got it.
B, and then another common mistake is just to write the 5 instead of forgetting that it's negative 5. C equals 9. Very good. So x equals negative 5 plus or minus negative 5 in parentheses squared minus 4 times 1 times 9 all over 2 times 1. Good work showing all of our values. X equals 5 plus or minus 25 minus 36 over 2 times 1. Now what's going to happen here? X equals 5 plus or minus square root of negative 11 over 2. A square root of a negative number is not good for us. So what that means is there's no real zeros. So that means if I were to graph this on my graphing calculator, I would get that it does not cross the x-axis. Its vertex is there, never crosses the x-axis, no real zeros. Good math.